Hi guys, welcome to this video. This is one of the weekly questions that I have offered my students. It's on binomial expansion. This is year 12 binomial expansion. We are given that k and n are both positive, and 1 plus kx to the power of n can be expanded like so, where b is a non-zero constant. And we need to consider the coefficients of x squared and x cubed to show that nk equals 2k plus 3. And followed by that, we need to find the values of n and k. So I'm going to expand this 1 plus kx to the power of n using the formula. Now, because a over here, so remember a plus b to the power of n is a to the power of n, followed by nc1, an minus 1, b, and so on and so forth. Because a is just 1, I'm gonna ignore that because it's anything which is 1 to the power of, well, anything is just 1. Okay, so I'm gonna put this down as, therefore, 1 plus nc1 k times x, then nc2 kx squared, in brackets of course, and then nc3 kx cubed, like so. So we just have to go up to x cubed, and I'm gonna further tidy this up, so that will be equal to 1 plus nc1 is going to be just n, so n kx, and then nc2 is just n factorial over 2 factorial n minus 2 factorial, followed by k squared x squared, and then I have my last term, which is going to be, I'll just write it down here, so n factorial over 3 factorial n minus 3 factorial k cubed x cubed. Okay, so here I've got all the expansion done, and now I need to consider the coefficient of x squared and x cubed. Now, in the expansion on the right hand side, they're both b, i.e. they're both equal to one another. Okay, so since the coefficients of x squared and x cubed are equal, I can simply put the x cubed coefficient is this and x squared coefficient is this. I can just put them equal to one another. So I'm going to have n factorial over 2 factorial n minus 2 factorial k squared, n factorial over 3 factorial, which I'll simplify in a second, and k cubed. Okay, so let's see what we can simplify, and we can clearly see that n factorials will cancel each other out because they are on the numerator. So if I was to divide both the sides by n factorial, they just basically cancel each other out, followed by 2, which is 2 factorial, which is just 2 times 1, or just 2, and 3 factorial, which is 6. Okay, so I can just put that down over here, so 6. And because 2 goes into 6 3 times, I can also simplify that. So what I'm left with is 1 over n minus 2 factorial k squared. Okay, I'll just put that in a bracket. And 1 over 3 times n minus 3 factorial times by k cubed. Again, I can choose to put that in a bracket. So that's as far as I've gotten. Now, what else can we do to further simplify? I don't like my factorials over here, so we want to simplify this as much as possible. Okay, however, we know one thing about factorials is that you end up multiplying backwards. Okay, so for example, it's, say you have 4 factorial, you go like 4 times 3 times 2 times 1, right? So you're taking away 1 each time. Yes, so similarly with the left hand side over here, I've got 1 over n minus 2 factorial, which is simply n minus 2 times n minus 3 times n minus 4, and so on. So I'm going to therefore write it down like n minus 2 times n minus 3 factorial. Okay, so that will now cancel out with the n minus 3 factorial on the right hand side. So they are equal to one another, and hence they can cancel out. So what I'm left with is now simply 1 over n minus 2. Okay, so let's just draw a line here. Okay, so times k squared equals 1 over 3 k cubed. Okay, so now all I have to do is cross multiply, and 3 k squared equals n minus 2 k cubed, And from here, I can divide both the sides by k squared, so that disappears, and that's left with a single k. So 3 equals n minus 2 k, and then if I expand and tidy up, I'm going to get the expression that I wanted, which is nk equals 3 plus 2k. There you go. So that is my first part done, okay? Now, for the second part, I just have to work out the values of n and k. Okay, so because obviously this equation right here contains both n and k, I'm going to need another equation, okay, so that I can solve it simultaneously with this one. So what can I use? Well, I do have one more thing, which is the coefficient of x, okay, which in this case is n times k, and from the right-hand side of my given expression, it's 7 over 2. Okay, it's equal to 7 over 2. So I can use that to my advantage. Okay, so I'm going to rub this bit off. There we go. So let's put this. Okay, so if I equate these together, that is nk equals 7 over 2. So nk equals 7 over 2, and that's the coefficient of x. Okay, coefficient of x are equal. Then I can say that 7 over 2 is equal to 3 plus 2 times k. So now I can work out the value of k. Okay, so that is 7 over 2 minus 3 equals 2k, which is going to give me 1 over 2. Okay, and that will give me equal to 2k, and therefore I will have k as a quarter. Okay, so k is a quarter, and now I can work out what n is. So just using this over here, I can say that a quarter times by n is equal to 7 over 2, and therefore n is equal to 7 times 4 over 2. So that's just gonna give me n as 14. And there you have it. K is a quarter and n is 14. So this is a really nice question, as you saw, because it is definitely not very tedious, but it is a very long question. And so I reckon it's worth about 8 to 9 marks, and it is a really good contender of the exam questions. So definitely worth practicing questions like this, as they do tend to come up in bits and pieces like part A and B and so on. So definitely give it a go, and I hope you enjoyed this video. Thanks ever so much for watching.